Good morning. As you all can tell by the presentation, when you look up there, I'm really big. So if you guys get kinks or anything like that, I'm sure they have Tylenol or anything up front there. The presentation here is going to be about utilizing macro scripting for lean process improvement. By the time we walk away from this presentation, I want you to have not, ooh, wow, that's a macro, but understand why we develop macros. I work for Kaleida Manufacturing as a metrology planner. I go to ITT Technical Institute, as our presenter stated. Kaleida Manufacturing is a stamped and subcomponent. It's a subsidiary of KTH Parts Industries. It was established in 1996, and it is a Tier 2 Honda supplier. We have over 500 associates. Our building capacity is 470,000 square feet. We produce 450 stamped products and 250 subcomp assembly products, and we ship over 105 million parts a year. KMI produces stamped and welded frame subcomponents for every Honda automobile produced in North America. So I'm going to explain first where we came from with our data collection process. 3 years ago, when I first was initiated into KMI, our process was to take data collection through using taper scales and recording our data by hand and recording it in file cabinet. Since then, we've been able to develop a system utilizing macros, portable CMMs, touch probes, and laser scannings to quicken this process and produce different tools that were capable of progressing what we do. So our team's goal was to develop a system of processes that are simple to use, increase data collection productivity, shows time savings, and are compatible with both Faro and Romer arms. We try not to be biased, though those two will probably go hand in hand and have a war over that. Our system of application tools was to make sure that we had data evaluation tools, fixture layout tools, jig layout tools, program development tools, and data collection tools. We needed to ensure that we had efficiency, quality. We used time and cost savings analysis and return on investment analysis to judge whether a macro was based upon the first thing or was based on benefits or not. I'm simply going to go through 3 macro sets from this point on. The first 2 is part of a larger project known as our KMI PolyWorks Tool Manager. The first tool was developed by myself. It's called the Easy Snapshots. These are simply pictures for guided images. It was developed by me, and I started the initiation of this project back in November of 2011. It is over 23 macros, and it is over 23 lines of macro coding. It's currently active. So imagine if you're doing touch probe data collection. You always have a CAD in which you might have a surface point in which it is blocked or by the CAD and you're not able to see it. PolyWorks has a tool that is called a guided image, but the problem with creating these images is it is long and it takes a while for the creation time. Sometimes the locating of this 3D scene is very cumbersome, and it's hard to separate and hide features and comparison points. We also have image quality. Zooms are too far in and out where the guided image is hard to see. The view perspective, it's hard to tell where the next point is or the next feature is, and it's inconsistent. So here's the current process flow for what we have to do with PolyWorks. If you see that it's really heavy on the user interface. The only thing PolyWorks simply does is generates the snapshot and places it in a report item. This process can take us about 30 minutes to do. What we proposed to do was to just simply have an operator initiate a macro, set a primary view, and a macro runs, and the operator just simply has to verify the image. We found that this process takes about 1 minute. We're going to go through a demonstration here, just simply how this goes through that, and go from there. So when we initiate the macro, we have to establish a primary view. We set an access point in which we generate a 3D scene which is user-friendly, in which we pick a primary view. The operator uses a color coding in which they're able to rotate through the project, selects a primary view, and from there the macro begins. We do what we call a vector bloom, in which vectors are centered out of a center point, and it comes off that. If the vectors crosses the CAD, it creates a point and rotates the CAD so that an image can be created. If we continue seeing this, it's kind of hard to verify that a point is created correctly or incorrectly. There's just too much going on at the current scene right now. It just simply continues through each one of the points features on the tree view, and it takes that picture of that point, stores it into the reports. We then take that report and file it into an outside data folder or source. So we'll continue with this. It's still hard to verify this point because of that. Let it run here just a little bit here. So it's kind of hard to verify, so we had to create a system in which we kind of hide the blooms, but we're still able to verify whether the image that we are creating is good or bad. It should be flipping over here sooner. And by hiding the blooms, we are able to actually speed up the macro. So again, how do we make this faster? So we're just simply going to hide the blooms, hide the creation of the 3D scene, the 3D modeler, so that we're able to view it easier. We don't see the actual generation of that. We don't see how it's changing. And this is actually going to speed up the process slightly. So what's the benefits of this? We create efficiency. We save about 25 minutes for each program that we use this process for. We found that the break-even point for our time management was at 166 programs. We're currently at 702 programs that we have used this process for. We're capable of multitasking through this process. The images are consistent in their perspective. The location is stored on a folder or same location, and we're seeing continual benefits of 207 hours saved per year for this process. So the next macro that we're going to go through is, what if I rework this and give it to another associate to build a macro with? This is actually one of my pride and joys. This is called the easy reporting macro for scan process. I actually reworked my picture macro and gave it to my fellow coworker, Brian Meyerholtz, to create a way to report scan data. Brian initiated this project back in November of 2013. His developed time is 40 hours, and the size of the macro is 7 macros at about 3,000 lines. The purpose of this is to create a scan report. We do about 5 scans each day. I'll give you a scenario in this instance. Say you have a die quality up or something along that lines where there's a meeting within the next 30 minutes. It's essential to get that part scan, get that information to a manager or someone into that meeting as quickly as possible and convey that information to them. So our goal was to actually cut down our reporting creation time so that we were able to convey any messages that we needed to that supplier. The problem with auto creation or hand creation that we currently have in PolyWorks is the creation time is long. Manual snapshots and reporting add to this time, and manual input of part information. Sometimes we have missing report sections, and snapshots are inconsistent. So again, we're going to look at the workflow for this. Initially, we have a heavy user interface where about the only thing that we are capable of doing with PolyWorks was filling in the report, and we would have to make decisions from there. We are finding that this process takes about 6 minutes, and we thought we could improve it. With the solution Brian was able to initiate, again, we were just simply initiating a macro, setting a primary view, and verifying what the report looked like. This process we found took about 1 minute. Before we go into this demonstration, I want to give you a little background. I have 2 new associates with me. I decided to push them against one another. Gene started actually putting in the manual process for this, and we gave him a 30-second head start, and Brian started the macro script at that point to see where we go from there. So at this point, Gene's simply just going through the macro script and doing everything that he has to do. He just simply had a raw data sheet, snapshots, reports, and that stuff has not been generated up to that point. He's up to 10 clicks at this point in time. I told them to count up to 100 clicks while they were going through this process. Shortly here, Brian's going to start up his macro script, and within 3 clicks, he's caught up to Gene, who had 30-second start. He's setting his primary view right now, And Gene's taking his first snapshot, and Brian just passed him at where Gene had 20 clicks and Brian had 3 clicks. Shortly here, it is flowing through the process. It's cutting up the program, and it's able to generate pictures from that. It's taking that easy snapshots and cutting up the part. Right now, Brian is entering part information. This is just essentially what the part number is, whether or not he wanted to add special notes or anything along that lines. As soon as he's able to progress from here, our Polyworks macro is going to auto-generate a report template in which we can print off, hand to a manager, and go from that. We're at 8 clicks right now for Brian. It's going to generate 2 more images, and he's going to be able to verify his report. While Gene is just up to 50 clicks, and he's able to, he's just taking a second snapshot on his surface points. Brian's verifying the part. We actually generated a unique template in which is unique to KMI. We have the part information. We set the alignment showing where our alignment was. The part actually generates information that is pertinent to Brian, his email address, his name, without Brian ever entering that information into the report. Gene's still going strong here. He's at 80 clicks. Brian's just got finished at 90 clicks, and Gene's just halfway through his actual pictures for the snapshots for the surface points. We should be actually speeding this up shortly, but I'm actually going to stop this. Gene's going to go through the same process. The movie will actually go on for another 2 minutes, 3 minutes, and Gene will actually make a few mistakes in that process. Where Brian's information was automatically generated, Gene would have to actually enter that information by hand and go forth from that. The benefits to this is the efficiency. We're saving about 5 minutes per each program. So we're seeing a break-even point of about 480 new SCAN programs, or 96 working days from KMI. This leads to multitasking. Actually, when Brian was running this test, he was signing off on papers that were pertinent to our quality process. The reports ensure that important information is existent within the process. The reports are consistent, and we have an exclusive style to our reporting. The continuum benefits, this is the big one. Brian actually was developing this when he was only 3 months in at KMI. No prior macroscript education, anything, no experience along that lines. So this is all part of a big process that we call the Polyworks Tool Manager. The Polyworks Tool Manager has been developed by Adam Steck-Schulte, myself, Brian Meyerholtz, and Eugene Swagger. The initiation of this project was 3 years ago, March 2011, and it is over 1,000 macros and over 100,000 lines of code. We are currently developing this process, and we're actively using it. The part in which I'm going to demonstrate in this process is our actual touch probe data collection process. So we went over how we were using taper scales prior and filing it by hand. Well, we were finding issues with varying data. How hard did the user push in on the scales? How does the operator read the scales? Deficiency on data communication, slow operating records, inefficient storage style, and slow communication. We did a recent case study in which this took about 35 minutes to complete and do. What we decided to develop was the KMI Polyworks Tool Manager utilizing touch probes. What we utilize is we have 3 stations set up with cloned programs. In this process, we have linked data trend charts, and you'll see through the video here, we're still using V11. The importance of that is that the data is linked within the trend charts. We created a program directory for users to be easily able to identify programs, click them and open them without going file open into different programs. We utilize a touch probe. This allows for fluent data collection and consistent data collection. In our recent case study, this took about 15 minutes. So I'm going to give a demonstration here on our current data collection process. Gene is actually our operator. He's going into our data hub or data directory, picking a model code, flowing through and picking a part number to open up here. He opens up a part number. He's able to get the part ready. He's able to multitask and while the program's open. Again, we're utilizing V11 just because of the trend chart data collection and the ability to link the data between the two stations utilizing the stamping probing data collection right now. As the program opens up, Gene gets a prompt telling what the part name is, the part number, and what die it comes from. Gene initiates step one.
Please make sure to verify your responses.
And he makes a mistake, and the program fixes them, corrects them, and he's able to go through and go from that. He's entering his clock number, he's entering the part in which the press in which it came from, the thickness of the part utilizing scales that are connected to the computer. He's going to get a reading here telling him if it's good or bad. He's going through with that calipers and actually measuring the holes, and he's able to hit the electronic connection, and it's able to record that information directly into Polyworks. The voice prompting system actually initiates him, telling him that he's on to the step 2 of the process. Right now he's measuring an alignment verifier. This verification is stating that when he aligns the part that it is a good alignment. We were experiencing that sometimes when we would set up an alignment that alignment was bad. What that alignment verifier just simply tells us that we have a correct alignment and we're able to progress from there. He's just going through a prompting system. On the right hand side there, you see where we initially used the easy snapshots. He actually has a guided image on the side. It tells him which side he's actually operating on, and he's able to go from there. He's simply going to go through now, measure the part in each location, and go from there. I'm going to continue with the movie here, or continue with the presentation. What it'll simply do is just go through the process, having guided images. It'll have a prompt on how to do it, and we're also using the 3D scene. The benefits of this is Polyworks is a measurement, it records the measurements as they are taken. Data is stored electronically on a server. Data is accessible immediately. We utilize a touch probe, so the force upon in which we put on the part is consistent and the ease of use. We actually trained an associate this past Monday to use this, and they are up and running using this process right now. So to do an overview, a conclusion, the efficiency we went over efficiency for the guided images, the short training time frame, time and cost savings through electronically stored data, quickened processes, continuous improvement activities, and we kind of went over quality for consistent data collection and scan reports. So where does KMI go from here? We have all these nice tools, so we should do continuous improvement, correct? So KMI is trying to add to the Polyworks tool manager for data collection process. We have established a method in which we're able to take any type of part and collect any data that we need for that in less than 6 minutes. We're able to add additional points to that without adding any time to that. Data is linked through the programs. Some of the features that I learned about today today and yesterday have been very essential for that. We're creating an external data hub for this, so if a manager needs to view the data, they don't have to have a Polyworks license to view what the data has been trending like. We're actually going to be utilizing CM4D for that. We're looking into making programs automatically. We're doing simplified program editing, and we're trying to figure out one-time alignment. So if you have a right and left side and it has different alignment parameters, where we can just measure that fixture once and be able to progress. I'd like to take a moment and thank Brian Meyerholtz and Eugene Swagger for helping me get ready on this. Thank you for the opportunity to present today. If you have a question, please stand up, and one of the fine individuals out here with a mic will be able to help you out with that.
If I may, for someone who hasn't tackled macros yet or is thinking about it, do you have 1 or 2 tips to getting started or overcoming the
That guy over there, David Pierre, I probably talked to him a lot. Doctor's offices. The first year that they had doctor's office, we gained a reputation by talking their ears off in there about macro development. They knew who we were after that because we were asking them questions in which they're actually putting in feature requests.
Well, I'm gonna take advantage of this opportunity. Has anybody worked out in financial terms what the payback is on the macros? You know, translating time right into dollars.
We have, but I was told not to release that information.
Is it significant?
Yes, it's my paycheck a year. Got a question over here.
Do you have any plans to convert that to V12 to V11 section?
We actually have a working representation of V12. I actually have to talk to David Pierre about that. What we were seeing is we weren't able to put that data collection in the trend chart. We weren't able to link it. But some information today, a new perspective, we should be capable of actually progressing to V12, V14 from that. Any other questions? All right.